Hey, this is Todd from One Shot API. In this video, I'm going to walk you through how to use our new permissionless gas abstraction relayer for smart accounts. The great thing about this product is that it requires no special SDKs. There's no business team sign up. You don't have to pre-fund paymasters. All you have to do is point your app, whether it's an agentic wallet or a consumer wallet or something else, point it at our relayer URL, grant an appropriate EIP 7710 permission context, and include a transfer for one of our supported stablecoins to cover the gas, and that's it. We will cover the rest. Now, there's three core standards that this relayer is built on top of. The first one is 7702, which is a way to upgrade EOAs to smart accounts. And I really like this account abstraction approach because it's much simpler and much cheaper than the legacy 4337 account abstraction approach. And I think a lot of wallets are moving in this direction. Then the other two are a little newer, EIP 7710 and EIP 7715. Both of these standards were proposed by the MetaMask Smart Accounts team. 7710 is a specification for how to sign cryptographic delegations or caveats that will let, let's say, a third party execute transactions on your behalf even when you're not online, as long as those transactions meet whatever your intent specification is. So I really like this standard. It's very interesting, and I think it has a lot of implications for agentic autonomous wallets that are 100% non-custodial. The other one, 7715, this is a wallet interface standard. So the MetaMask browser core wallet implements the 7715 request permissions interface. So if you're building a DApp that wants to use delegation permissions, you can request those straight from the MetaMask browser app, and it'll work out of the box. And then you can provide the return permission contexts straight to the one-shot API permissionless relayer. So let's jump into actually using it now that we've covered that. This is the quick start page. The first thing is you'll notice that we have published a skill for the relayer. And if you're using an agentic coding environment, I recommend installing the skill. You can ask it questions. It'll help you implement stuff way faster. So check out that skill. The next thing on here is kind of a diagram of the life cycle of what an integration is going to look like. So if you're using an embedded wallet or like you're handling your own private keys, step one is going to be that you're going to have to get a 7702 authorization. And that authorization needs to upgrade the account to the MetaMask 7702 stateless delegator. So that's just part of their delegation framework smart account standard. So that's step one. If you're using the MetaMask browser extension or mobile app, step one is handled by the actual MetaMask wallet itself. And so then once you're upgraded to a smart account, the next thing you'll need is to sign a delegation or a caveat. You'll see both of those words used. And you need a caveat for the gas fee payment in one of the supported stablecoins. And you need a caveat that covers whatever it is the transaction is you're trying to do, like a Uniswap action or depositing something in the Aave, whatever it is, you need a caveat that'll cover whatever the target transaction is. And then once you have both of these, you can submit them both together to the one-shot public relayer JSON-RPC API. So you can upgrade an account and perform the transaction in a single action. You don't have to do them separately. And if you supply an optional destination URL, we'll give you real-time feedback on what is happening with the transaction status so that you don't have to poll. And so part 4 is actually checking on the life cycle of the transaction that you submitted. So you can poll for your transaction status, or like I said, if you supply a destination URL, we'll give you real-time webhook callbacks that you can use to make the application snappier. And so here, I've got some curl commands that you can run without any kind of API key or signing up for anything to check out the different functionalities exposed by the relayer. The first one is called Get Capabilities. This one tells you which stablecoins are supported on which chains and to whom do you need to delegate a caveat to for it to be executed, as well as where do you need to send the fees. So if I open a terminal and run this first Get Capabilities command, you'll see here that it returns for each one of the chain IDs that I asked for. It returns the fee collector address. So this is where you need to send your gas payment, is to that address. The second thing is the target address. So when you're creating your caveat or your delegation for the smart account, you need to make sure that the delegate is this target address so that we can execute the transaction for you. And then the tokens lists all of the supported tokens on that chain, as well as the address for that token and how many decimals it has, so you don't have to look them up. So that's a great endpoint. You don't have to hit this very often. It doesn't change very often, but you do need to make sure that you get the correct fee collector address and target address for the different chains. So then the next thing is, once I figure out which token I want to pay with, where I need to delegate, and where I need to send the fee to, I can get the current quote for gas on that target chain. So if I copy this and open up my terminal again and run this, this command was going to run on chain ID 8453, which is base, for token 833, that's USDC. So what I'm telling you here is the rate. So this is the price of the native gas token in the stablecoin. So in this case, I'm basically saying that ETH on base is $2,256. So you're going to use that price times your estimated gas usage, and that's going to be the amount of fee that you need to pay the relayer to perform your execution. Now there's another quantity here called min fee. If the estimated price of the transaction is less than a cent, we require you pay at least 1 cent to run a transaction. So if it's one of the inexpensive layer 2s, pretty much you can just submit a fee of 1 cent and not worry about this estimation step. If you're on a more expensive chain like perhaps Arbitrum or Ethereum, you'll want to do this calculation to figure out how much your transaction is going to cost, and then make sure that your fee covers that cost. Now there's a context field here, and the context field locks in the gas price for you for 45 seconds. So you can get the price lock context and then give it back to us, and we'll honor that gas price estimate for the duration that it's good for. And now once I've done both of those things in my app, again, all of this stuff is actually covered in the skill, so you don't have to be an expert at any of this to implement it. Let's actually try to run a gas abstraction transaction. I'm going to do it on base network, and I'm going to connect my MetaMask account. I'm going to pay in USDC. I'm just going to send a penny, and I'm going to send it to one of my other accounts in here. So I'm going to send it to this account. And I'm going to sign a delegation, and you'll see it pop up here as a permission request. And I'm going to grant that. And I'm going to actually sign the permission request, which is for 2 cents. It's for 2 cents because I'm sending 1 cent, and then I'm paying the min fee for the gas abstraction. And then that will return to me a curl command. Just so you can see what it actually looks like, we return to you the curl command. So let's copy that and run it in our terminal. And it returns as the result the transaction ID. Now if I take that transaction ID and put it in step 4, this will give me a command to check on its status. And if I run that, you can see it's already got the logs for it, which means that the transaction has run successfully, and it's given me the transaction hash. So if I copy that hash and come over to Basecamp and put that transaction hash in there, you can see there it is. This is the confirmed transaction. If I check out the logs, there's the transfer, and that's all there is to it. Now I did this where I paid for the gas and executed the transaction on the same chain. You can actually do multi-chain gas abstraction, so I can pay for the gas on one chain and then run the transaction on a separate chain. So for instance, maybe I have USDC on base, but I want to run my transaction on Unichain. I can totally do that. All you do is use the send 7710 transaction multi-chain call instead of the single chain call, and the skill goes through how to do all of that. Now if you come over here to the public relayer details, here's a table for all of the supported stablecoins and the networks that they're supported on. This table might change from time to time, but you can get the same information from the Get Capabilities endpoint. And if you want a code example of what this actually looks like in code, come to the first Transactions tab over here, and there's an example for a single chain relay, which is what we just did, as well as a multi-chain relay. You can see what that looks like, as well as all the supporting scripts to make it run. You can copy these to your local and run them using Node. So try out the relayer. Again, this is the same infrastructure that's running OKX Wallet's gas station, so it's built for scale. You don't have to worry about usage spikes or keeping a paymaster funded. We handle making sure that the gas is available at all times. Hope you enjoyed this video. Subscribe to our YouTube channel and watch out for more tutorials in the future.